So guys, let's say you are asked to find the derivative of what of dx of x raised power n. No, to differentiate this is very simple. Just go ahead and what and bring the power down, right? That will be what n x raised power what that's n minus 1. You understand what I'm saying now? This is just for the case 1 rather. So in this case, whenever you're having x raised power n equals to that's n is x is n x raised power n minus 1. This case 1 is also known as what the power rule. It's also known as what the power rule. So in this case now, let's say your n is equals to 3, and you should note your n is not equals to what minus 1. That's just it. That's the rule there. So let's say you have your n is 3, and you ask to find what did the x of what of x is power 3. So in this case now, bring the power down. That will be what 3x is power what, then subtract 3 minus 1. Can you see this down? So here you are going to have what that's 3x raised power what 2 exactly. Now let's now say you are giving what you are finding you have to find what did the x of what of x is power what x is power 5. Go ahead and find this, pause the video and go ahead and differentiate this. So differentiating this, you are going to have that's 5x is power what 5 minus 1, which is what 5x is power what 4 exactly. Now let's say you are asked what to find did the x of what of a constant like c. No, where c can be what can be any number, it can be any number, it can be what it can be equals to, let me just say, plus or minus any number, yeah. So you understand it now. So let's say you are asked was to find d the x of what of c. Whenever you are dealing with what with constants, the power of x here is equal to what 0. She gets right. And so if you have to find what d the x of what of any constant. Just now here you are going to have what you are going to have it what to be you bring down the power, which is what 0 times what times x is power what 0 minus 1. You understand it now? Then 0 multiply everything is what is 0. That means whenever you are asked to find the d the x of what of any constant like 5, in this case now the power of x is equals to 0 here. Bring down 0, that's 0 multiply what 5x power 0 minus 1, so which is what 0. You understand it now? So whenever you are differentiating any constant, the answer is what 0. So now let's say you are giving what you are asked to find what d dx of what of that's root of x, d dx of root of x. So in this case, just need to what to rewrite your root of x as what x is power what 1 over 2. She gets right now. So rewriting this, you are going to have it to what to be that's d dx of what x is power 1 minus 1 over 2 minus what minus 1. She understand it down. After bringing down your what 1 over 2, you bring it down, then you subtract 1 here. She understand it down. So here in this case, subtracting 1, if you want to simplify this, you're going to have 1 over 2, right? X is power what that's minus 1 over 2 exactly. So which you can also write as what as that's 1 over 2 root what root x, because this inverse abi, so you can just find it as what root x. So now let's say you are given another one. Let's say you are asked what to find the d dx of what of 1 over what over x. Now you asked what to differentiate 1 over x. Differentiating 1 over x can just what change, rewrite it as what as that's x raised to power minus 1, right? That's x inverse. You bring that the minus 1, that's minus 1, x is power what minus 1 minus 1, right? So which is equals to what that's minus 1 x is power what minus 2, right? So in this case this is actually inverse. You can have it as what minus 1 times what 1 over s square, which is equals to what minus 1 over what s square exactly. So now let's say you are asked was to find d dx of what of exponential x. Finding d dx of what of exponential x is actually what a different case entirely, because if you differentiate exponential x, is still what you are still going to have exponential x. You get right down. So if you are asked what to find d dx of what of exponential x, is still what the same thing as exponential x. Sure, understand now. So unless say you are asked for to find what the d dx of what of log x. Get now. If you ask what to differentiate d dx to find the derivative of what of log x. So find the derivative of what of log x. That's actually what that's 1 over x, right? And you can recall that whenever you are asked what to find the integral to integrate 1 over x, the x integrating 1 over x here is the same thing as what as log x, because whenever it was you differentiate the what is at the bottom and its equivalent was to that of what or that at the top, that is what log x. Then let's just say you are asked what to find to differentiate. Okay, let me just try to solve something here. Let's say you are given that okay y equals to what, let's say y equals to let me just say x y. She understand now. Let me just use like this. Let's y equals what? X is power what? X is power y. Then find the y dx. So in this kind of case, it's entirely different. This is an exponential. You need to what? To take log of what? Of both sides. Taking log of both sides, going to have what? Log what? Log y equals what? Log e y abi equals what? That's log x is power what? Y exactly. So in this case now, log y. If you want to look in this case, you're going to have it to what? To be that's log y equals to what? Log x is power y is the same as writing as what? Y log what? Log x, right? So the thing is that if you want to differentiate both sides, if you are differentiating 1 over x, y is what? Is the dependent variable, right? And your x is what? The independent variable. So here, finding the derivative of what? Of log y, that's actually you're going to have what? 1 over y dy by what? By the x. Check that because y is what? Is the independent variable, and this will be equals to what? Differentiating this, you differentiate this. Okay, let me just use what? My chain rule to just differentiate this directly. I'm going to hold what? My y, right? Y. Then after holding y, I'll go ahead and what? And differentiate my x, log x. Differentiating log x, I'm going to have what? 1 over what? 1 over x plus when I hold my what? My log x, and I differentiate my y. Differentiating y, I'm going to have that's 1 dy by what? By the x. So that means whenever you are what? You are differentiating independent variable, that is x, let's say log x, log of independent variable, log x, that's what? 1 over x. Whenever you are asked what? To differentiate log w is equals to what? 1 over what? 1 over w. Whenever you are asked what? To differentiate log what? Log v equals what? 1 over v. It will be inverse of what? Of the function. But whenever you are differentiating, let's say just independent variable, you are differentiating independent variable, like let's say you are asked what? To find you are differentiating y, and y depend on what? Let's say x and so on. So in this case now, it's going to be what? 1 over y, then dy by what? By the x. If it is v, if v is your dependent variable, it's going to be what? 1 over v dv dx. She get down. So if it is u, let's say u is the dependent variable, it's going to be what? 1 over u du dx. That's very good. So now let's just check another case now. Let's say you are having you are asked to differentiate to find d dx of what? Of a exponential x. She doesn't write down. So you are asked to find d dx of what? Of a exponential x. So this is equals to what? That's a raised by x log what? Log a, right? We have different type of rules that is used to solve, that is applicable to different differentiation problems. Now the first one, you have the first principle, is which is a general method. We also have the product rule, we have the quotient rule, we have the chain rule, and also what? The power rule, right? So I will try my best to explain each and every one of it, or all the rules. I will explain it, try to give you guys an example. Now considering the first principle, now let's say you are given y equals to what? Something like that's y equals to x. You understand? Now let me just say, okay, because of our time, y equals to x, right? So, and you're asked what? To differentiate using what? First principle. The general method is just like you're going to add what? Small decrements to what? To y, and your small decrement to what? To x. Differentiating this using what? First principle method, right? So here I'm going to have y plus what? Delta y, right? Equals to what? X plus what? Plus delta x. Can you see this down? Then after that, after you have, the first thing here is that you add what? Add delta y to what? To y, right? And also what? Delta what? Delta that's x to what? To x. You get straight down. So then after that, you make your what? Make delta y the what? The subject of the relation. Anyhow, you are going to have your what? Your delta y to be equals to what? X plus what? Delta x minus what? Minus y. Can you see this down? So you can just recall that your y is what? Is x. Recall, right? Y equals to what? X. So that you're going to have delta y equals to what? That's x plus what? Plus delta x minus what? Minus x. So you understand it down. So in this case, my this you cancel this, right? So that I'll have what? I'll have delta y equals to what? Delta x. So you get it right down. So the next thing is that you divide both sides by what? By delta x. You get it right now. So here you're going to have what? You're going to have delta y divided by what? Delta x equals to what? Delta x divided by what? Delta x. So you can just view that this we cancel this, right? This and this, they are out of the way, so that it is equals to what? 1. So you are going to what? Take limit. Check it down. Delta x tends to what? Tends to 0. So here we don't have any text data x again. So there is going to turn to what? The y by what? By the x equals to what? 1. And the general method is that whenever you have what, you are given a y equals to what? X, and you have to find what? F of x. What is f of x when y equals to x? So in this case, it's very simple. Just need to what? To use the normal differentiation method, right? What is f prime of x? Rather, you have to find f prime of x. That means your f prime of what? Of x is equals to what? We have what? 1 here. Bring it down. You're going to have 1x raised to power 1 minus 1. She get down. So here you're going to have f prime of what? Of x equals to what? That's x raised to power what? 1 x raised to power what? 0. N raised to power 0 is what? Is 1. That means we're going to have f prime of what? Of x equals what? 1 multiplied what? By 1, which is equals to what? 1. So can you see that we arrived at the answer? Now, you guys will just try to solve this and drop the comment in the comment section below. Drop your answer in the comment section below. You are going to find the derivative of what? Of x square. Do that and just drop your answer in the comment section. Now let's look at product rule. Product rule is applicable whenever you have what? You have the product of two function. Let's say you are given that of two, let's say you have of two independent variable. Let's say if your y, as far as product rule is concerned now, y equals what? Let me just use v. In this case, y depend on what? On uv. You understand it now? And you're asked what? To find product rule. It's very simple. So using general method, general knowledge of what? Of the of first principle, we are going to say, okay, we'll add delta what? Delta y to what? To y. Check it down. Then delta u to what? To u. Delta v to what? To v. Can you see this down? So following that, you're going to have y plus what? Delta y, right? Equals what? U plus what? Plus that's delta what? Delta u. Open another bracket. V plus what? Delta v. She gets written. So next is you're going to have your y plus what? Plus delta y equals to what? That's uv, right? If you open the bracket, plus what? Plus u delta v, right? Then here plus what? Plus v delta what? Delta u, right? So plus what? Plus delta u delta what? Delta v. Can you see this now? So the next one is that I'll make my delta y to the formula. I'm going to have delta y equals what? That's uv, right? Plus what? Plus u delta v, right? Plus what? V delta what? Delta u plus delta u delta v, right? Minus what? What's my y? No, minus my y. My y is what? Uv, right? So here my uv will cancel out this, right? So that I'm going to have what? Delta y to be equals what? U delta v, right? Plus what? Plus v delta v plus what? Delta u delta what? Delta v. Then after that, you divide all through. Divide all through by what? By delta x, right? Dividing all through by delta x, what are you going to have that time? You are going to have the y, delta y by delta x equals what? U delta v delta what? Delta x, right? Plus what? V delta u delta v delta u, exactly. It should be delta u. Delta u divided by what? Delta x, right? Plus what? Delta u delta v divided by what? Divided by delta x. And the general rules is that whenever you have what? Two or more independent variables that are left here, you are going to take them to what? To 0. So here I'm going to what? Take what? Take delta u delta v derivative. Just let me just say small increments of the independent variable, right? Take delta u, delta v tends what? To 0, right? I'm going to take both of them to 0 now. I'm going to have what? The y by what? By the x equals to what? U dv dx, right? Plus what? Plus v du dx, right? Then plus what? Plus 0. That means that's all, right? So this is the general formula for what? For product rule. Then let's try to solve some problem. Let's say you are asked what? You are asked that, okay, find derivative of what? Let's say find the derivative. Let me just say let's say y equals to what? Y equals to let me use 2x, right? 2x plus, okay, let me just use 2x sine x, exactly. No, these are two different functions. This is the first function, and here I'm having the second function, right? So here I can just say let my what? Just looking at the formula, I'm going to have divide the x. That is, if I want to find the f prime of x, that's u dv dx plus what? V du dx, right? So I can just say let my what? My u equals what? 2x, and my v equals what? Sine x. Can you see this now? So in this case now, I'll find the derivative of what? Of 2x. So differentiating this, I'm going to have my what? Du dx to be equals to what? That's 2, right? Then here, if I differentiate my what? My sine x, if you go back to the formula I just gave you guys the other time. That okay, I try to prove something, right? So whenever you want to differentiate sine x, what are you going to have? You're going to have that's the v, the x equals what? That's cos what? Cos x. You get now. So let's just try to substitute everything into the formula. I'm going to have what? My dy by what? By the x to be equals to what? View is what? That's 2x. Multiply by what? Dv dx. What's my dv dx? That's what? That's 2. She grab down. Then plus what? My v. What's my v? Sine x. Then multiply what? Du dx. What's my du dx? My du dx equals to, I think my du dx is 2. My dv dx is what? Is cos x. So in this case, I'm having cos x, right? So here I'll be having what? 2x. She gets right down. So I'm going to have 2 exactly. Here is my 2. So here I'm going to have dy by the what? By the x equals to what? That's 2x cos what? Cos x plus what? 2 sine what? Sine x. Can you see this down? So I think I can factorize 2 out. Factorizing 2 out, I'm going to have 2 into bracket what? S cos what? Cos x plus what? Plus sine x. So that's just it. Now let's just say I want to use the just normal method to just prove it directly. It's still the same thing. Whenever you're having two functions like two products, you are going to apply product rule. You understand it now? So that's just the answer. You take the one as your u, find your du dx, find the du dx. You are going to have it to what? To be 2. If you differentiate this, then you take the other as what? Your v. Finding dv dx, you are going to have what? Cos x, because whenever you differentiate cos x, sin x, you have what? Cos x. And find the whenever you find the differentiate cos x, you're going to have what? That's minus sin x. So that's just it. So now let's move to quotient rule. Let's say you're having something like uv, like let's say y equals what? Uv. And in this case, this is a rational function. That is, whenever you have what? A rational function, that's when you can apply what? You can apply the quotient rule. Do you understand it down? So